Okay, so here we've got a differential calculus question. Function is defined by function of x is 5 over x squared add 3x add c, where x is not equal to 0 and c is an integer. So we need to write an expression for f dash x. We're going to differentiate that expression. I'm going to get a bit more room by doing this. Okay, so what I do for these is I write out the equation and a function without all those extra bits. Before I differentiate, I want to get it ready for differentiating. So x divided by x squared is the same as times x to the negative 2. I'm going to change that. I'm not differentiating, I'm just writing it out again in an easier form to differentiate. Right, so now f dash of x equals, so now I'm differentiating. Negative 2 times 5 is negative 10. The power of x goes down 1, negative 3. 3x becomes 3, and the constant disappears, whatever number it is. I like to write that out again, just to put it back as a fraction. That's going to be easier to substitute into later if we need to. Okay, more room here. Consider the graph of f. The graph passes through the point 1, 4. In other words, for this function, so not the differentiated bit, the actual function, when y is 4, x equals 1. So 5 over 1 squared, add 3, lots of 1, add c. The only unknown here is c, so we should be able to work that out. 4 equals 5, add 3, add c. Go down a bit. So c equals negative 4. So that means my function equals 5 over x squared, oh, it's not keeping up with me, add 3x minus 4. Just go back so you can see that. Yeah, we've worked out c as negative 4, so now we know the whole function. If we know what the whole function is, that means we can put it in here. You can see I've already got it ready. 5 over x squared, add 3x minus 4. We're going to use that in the second bit. There's a local minimum at point Q. Find the coordinates of point Q. Find the set of values of x which the function is decreasing. So we've got 7 marks here, but it just tells us to find. So all we're going to do is look at our graph. Okay, I've got a very strange looking graph there, but no, that's all right because I'm dividing by x squared, so I am going to get a slightly strange graph. Can you see there's this bit here, and then there's this bit here's got a minimum point, so I reckon there is our point Q. So it's worth 7 marks, so we're not just going to write down an answer, we're going to give a sketch to show that we've done that. I'm going to use another colour. So our graph's kind of got a bit that goes like this, and then it's got this goes like that. And remember at the beginning it said that x couldn't be equal to 0. So this here, where x is 0, is an asymptote. So this is just getting steeper and steeper. This is getting steeper and steeper, but they're never actually going to cross the y-axis. Alright, so there's our graph. Let's work out this, which is point Q. Alright, down the bottom there. All we have to do is go second calculate. Oh, I've gone too far. The minimum. Go along, let's wait till we can see there's our cursor there. Okay, so somewhere to the left of the minimum, enter. Carry it over here, somewhere to the right of the minimum, enter, and then press enter again. There's our minimum point. We're going to give that to 3 significant figures. So point Q, let's write it on here, to 3 significant figures is 1.49, comma, 2.72. Okay, next, part 2, see part 2. Find the values of x for which the function is decreasing. So when's the function going down, essentially? So let's just highlight it on here. We're going down from here, down to the minimum. This bit, the function's increasing, and this bit here, the function's also increasing. So we just need this section. The way to describe those values of x is with an inequality with x. So we need to say that x is bigger than, remember that asymptote was 0. So it doesn't include 0 because the function doesn't work when x is 0. But anything bigger than x, or to the left of x, that's what we're going to need. Up to point Q. So point Q, the x coordinate was 1.49. So that's our answer. It doesn't matter for this one actually if we say for which it's decreasing or increasing. I don't think it matters if we say this is equal to, but this one definitely is just bigger than but not equal. Okay, 7 marks, that's that bit done. Right, moving quickly on. Let t be the tangent to the graph at P. Can you remember from the first part of the question, P was 1, 4. So that the gradient of t is -7. So we've got our graph. We can let's do this. Let's do it like this first. The way it's talking us through the question is to show that the gradient is -7 first. So if we use our gradient, which was f dash x equals -10 over x cubed. I can't remember what it was now. Let's go back. There we go. -10 over x cubed, add 3. Alright, so -10 over x cubed, add 3. That's our gradient function. So we need to show that the gradient is -7 when x is 1. Okay, so f dash of 1, so the gradient when x is 1 is -10 divided by 1 cubed, add 3. That's -10, add 3, that is -7. So we've shown it. Next, find the equation of t. The easiest way to do that is actually using the calculator. You can just go to the draw menu, which is here, second draw. You can get the calculator to draw a tangent, enter, and you can say we want a tangent when x is 1. So when x is 1, there's our tangent. It's given us the equation of the line there straight off. Okay, so that was part 1. Part 2, the equation of the tangent is y equals -7x, add 11.